In this lesson, you'll learn how to find the equation of a trigonometric graph. Got a little scenario here. Brisbane River has high tide at 8 AM of 2 meters and low tide at 1 PM of half a meter. Gonna have a go at sketching the graph. First of all, I'll just have a draw of what it looks like. I'm gonna draw the height of the river versus the time. So before I do that, I'll just define my two variables. And I've given them some dimensions as well. The x-axis will be the time after 7 AM, so my x values are just numbers instead of times. Imagine getting up to 7, 8, 9, 10, 11, 12, and then going back to 1 for PM. Won't really make much sense. Okay, just a rough sketch, trying to put all the information we have on the graph. So the high tide at 7 AM, so when x equals 0, we have 2 meters high. At 1 PM, so 6 hours later, we have a low tide of 0.5 meters. And then it's safe to say that another 6 hours later, we'll have a high tide again. So the graph I'm trying to model is one like this. I need to decide whether it's going to be a sine, cosine, negative sine, or negative cosine graph. I see that it starts at the maximum value and goes down. That looks to me like a cosine graph that starts at the maximum value and goes down. Okay, always keep in mind that it could be any four of those functions. So I'll have a go at trying to find the equation of the graph. Since it's a positive cosine graph, I'm trying to fit this function to y equals a cosine bx plus d. My job now is to try and find those three values. To find the a value, I'm trying to find the amplitude of this function, which I can calculate by taking the maximum, subtracting the minimum, and dividing it by 2. The maximum or high tide is 2 meters, the minimum is 0.5. Divide all this by 2, I end up with an amplitude or a value of 0.75. I'll put it in a box, I'll use it later. In terms of the period and the b value, okay, I can identify that the period is 12 hours. That's going to help me find my b value. Period of 12 hours, remember that the period is 2 pi on b, so I just need to solve this equation for b. I can multiply both sides by b, and then divide both sides by 12. I'll end up with pi on 6 as my b value. Put it in a box, use it later. And finally, to find the d value, looking for the average value. I'll find that by finding the average of the maximum and the minimum. My maximum was 2, my minimum is 0.5. When I calculate this, I'm expecting to get something between those two values. But my average value is actually 1.25. That's where there's symmetry on the graph, the average value. Put it in a box, and I'm going to use it now. So my equation is 0.75 cosine pi x on 6 plus 1.25. And I can use that to then answer any follow-up questions they may have. One example of a follow-up question could be, when is the water level below 1.7 meters? Why might I want to know this? Maybe I want to go swimming, but I can't swim, so I need it to be 1.7 meters so I can stand in there and still survive without swimming. So what this is really asking is, when is the y value less than 1.7 meters? Okay, to find that, we're going to solve the equation. 1.7 equals 0.75 cosine pi x on 6 plus 1.25. And you can go ahead and solve that algebraically using those double angle equation solving techniques. Alternatively, you could graph both the left-hand side and the right-hand side on your graphics calculator and see what's happening. So I've entered both graphs into my graphics calculator. I draw it. It looks pretty good. I'll arrow across to what my sketch graph probably looks like. I want to find these intersection points. So I'll gsolve intercept. There's one intersection. Press the right arrow and I'll get another intersection point. Through my use of technology, I can see that between x equals 1.77 and x equals 10.23, the water is below 1.7 meters. That's all well and good, but what does that mean to a person that hasn't seen this graph? It means that it's going to be below 1.7 meters. Remember, x is our time after 7 AM, so I need to add 7 hours to this solution. And if I put this in degrees, minutes, and seconds, it means between 8:46:12. And I'll do the same thing for the other solution. And 17:13:48, which is really 5:13 PM. Now this would make me happy because it would mean that I can swim all day long. You could also calculate how many hours I could swim for, what percentage of the day I can swim for, all those sorts of things using that graph that you created by yourself.